Good afternoon to everyone. Just today I will discuss some concepts of your subject. And first topic is approximation and errors in computers, right? Approximation and errors. The first of all, we will discuss what is the introduction of approximation concept. So the limitation of analytical methods in practical applications of led scientists and engineers to evolve the numerical methods. Scientists will do the numerical methods, engineers also compute these numerical methods. We know that exact methods and computational methods, and which is just used for the case of various applications in real life problem. So first of all, we justify accuracy numbers. We first explain about accuracy numbers. Accuracy numbers. What is the accuracy numbers? Or that is also called the approximate numbers. There are two types of numbers we can represent here, and that is the exact numbers. Exact numbers. And what are the examples of the exact number? And that is 1, 2, 3, 4, These are the exact numbers. And second case is approximate numbers. So again, you just remember the another case is the approximate numbers. Approximate number. So just to remember what is the meaning of the approximate number. Root 2, I think everybody know root 2. That is the one value. 1.4142. 1.4142 414213. This is the one number, approximate number, pi. 3.1415, 3.141592. That is also another approximate number, just to remember, root 2. That is infinite numbers. Pi, that is the infinite numbers. Finite number, this express cannot the finite, 1/3. Another, just remember 1/3. That is 0.333. So these may be approximated by the numbers root 2, pi, 1/3, and represented these given numbers, and the current degree of the accuracy is called the approximate number. Such numbers, whatever we have written here, such numbers, whatever we written here, such numbers such above numbers represent the given numbers, represent the given number, represent the given number to a certain degree of accuracy. Certain degree of accuracy. degree of accuracy, known as approximate numbers. Approximate number. Just you remember what is the approximate numbers and whatever we will discuss here. Another thing, significant figures. Significant figures. So what do you mean significant figures? The digit used to express the number is called the significant figures. And thus the number, suppose just you can see one number represents 7485 is one number represented here. 0.47 0.4758, that is also a significant number. 3.589, 3.589. These are the significant numbers. Contains the 4 significant figures, 3 significant figures. So significant, while the number 0.00386, 0.00, suppose these are called the significant numbers, right? Again, we can say that 0.00386, 0.00, another 0, 386, 0.000587, 587. Contain only 3 significant figures. See here, contain only 3 significant figures. This is the 3, and this also 3 significant figures. So here write 3 significant figures. Contain 3 significant figures. Okay. 0.00386, 0.000587. Again, we also extended the 3 significant digits. Since zeros only help to fix the position, 0 only help to fix the position. 0 only help to fix the position. To fix the position. Just remember whatever we discuss about the zeros, and zeros only help to you to fix the position only. Position to the decimal point. Similarly, number of 4, 5, 000. How many significant digits? Suppose another example I have to explain here. 4, 5, 1, 2, 3, 7, 3, 00.0, 00. Have 2 significant figures only. Here have 2 significant figures only. 2 significant figures only. So everyone just remember the only 2 digits we have used, then we can use the zeros value. The number of digits present here, that is called the significant digits. The digits used to express the number. The digit used, definition when you ask anybody, the digit used to express the digit used to expressed, the digit used to expressed a number called significant digits. Okay, that is called the significant digits. Again, just we have to coming to discuss about the round off. Another point we have discussed here, round off. Round off. There are numbers with a larger number of digits. Suppose just you consider one number that is 22 by 7, or that is we can express 3.14, 285, 285, 7143. In practice, we have C, or in the present problem or any problem, whenever we consider the 3.143, just you consider. We consider this value 22 by 7, that is equal to 3.14 sometimes, or sometimes 3.143. So we just round off this value. The process of dropping unwanted digits is called round off error. The process of dropping unwanted digits is called as the round off error. So we just dropping this process, this value we dropped. The process of dropping the unwanted digits is called the round off error. Rule to find out. 7.893. 7.893. Just whenever sometimes you can say two-digit number 7.89. The numbers are three significant figures also. So when we consider the some digits we have left, then the produce the error. Some errors will be produced here. Suppose original number a minus original value is different, and considering value, approximate value, consider value or approximate value, whatever we consider. When we different this value, original value and approximate value, when we subtract, then that is we come to the error value. So whenever we discuss the error now, what is error? Error three types: inherent errors, round off errors, rounding errors, and truncation errors. Absolute, relative, and percentage errors. Okay. So we will discuss about the error. Types of error. Inherent errors. Inherent errors. And second question also you have to discuss round off errors, rounding errors. Rounding errors. And also we have to discuss truncation error. And absolute, relative, and percentage error. Absolute, relative, and percentage error. So just we have to discuss some things about the inherent errors, rounding of errors, truncation error, and absolute, relative, and percentage error. So just to we'll discuss inherent errors. What is the meaning of the inherent errors? First point, inherent errors. What is the meaning of inherent errors? Errors which are already present in the statement of the problem. Understood? Errors which are present in the statement of the problems. And that type of error is called as the inherent error. Errors which are already present. Errors which are already present. Already present in the statement. Error already present in the statement. Before its solution. Before its solution. That is called inherent error. Such error arises either due to the given data being approximate or due to the limitations of mathematical tables, calculators, or digital computers. Inherent errors can be minimized by taking better data using the high precision computing aids. So this type of error arises. Error arises either due to the given data, due to given data. This type of error arises due to given data. Being due to limitation of the mathematical tables. Due to limitations of mathematical table. Mathematical tables. Or using calculators or digital computers. Calculators or digital computers. Also arises by calculators or also arises by digital computers. So this type of errors is called as the inherent errors. Everybody knows that easily, I think. Rounding of error. Second case is that rounding of error. Rounding of error. This type of errors causes rounding of numbers during the computation, such as errors is or available the most calculation to the limitations. Whenever we can say pi is equal to 3.144142857 But we consider this value, 3.1. We take the round off. So we arrive the true value minus of considering value is called as the round off value. This is called the round off error. When we can subtract this value then round of error can be original value of phi, original minus considered value, and this is called the error. And this type of error is called the round off error. So another question is that truncation error. Truncation error. What is the truncation error? Approximate results or on replacing the infinite process by a finite one, infinite process by a finite one. Suppose whenever you consider one example for the case of series of e to the power x, e to the power x is one expansion form, can write 1 plus x square by 2 factorial, x square by 2 factorial plus x cube by 3 factorial, 3 factorial plus that. And whenever we consider approximately one value, 1 plus x square by 2, when we consider this is x, we consider. So approximate error e to the power x minus x is equal to truncation error. Okay. The truncation error is type of the algorithm of the error. The x is true value and x complement is, just to remember, let x is true value. X dash the approximate value. Then error is x minus x dash. It's called absolute error. Absolute error, that is equal to EA, that is x minus x complement. That is called absolute error. Relative error, ER. Another error is defined as a relative error. And that is equal to represent as the ER. And that is x minus x complement divided by original value. Or error by true value. True value. Then percentage error. ER into 100. That is called percentage error. Okay. So thank you. You understand perfectly and peacefully try to understand my voice. So we'll discuss the next part for the next class. Thank you to all.